Hi kids, this is Miss Nichols and video 22, which is on circuit variables. The essential question for this video is, how can I describe and explain what is happening inside a circuit? What new variables do we need? What are their units going to be? And why do they matter when it comes to circuits? So in this unit, we're going to learn 4 new circuit variables: voltage, current, resistance, and power. You've probably heard those words before, but I would really urge you to try to work hard to understand conceptually what each of them means. Maybe make flashcards to help yourself review, because understanding really what those variables are is the foundation of everything in this unit. The good news is each of those variables is actually made up of variables we've already learned. For example, charge, energy, and time combined in different ways to make these 4 new variables. These variables together will describe how the electrons move through the circuit, transferring electrical energy from the battery or power source into all of the devices or resistors that are going to be using that energy. So the first new variable is called voltage. The symbol for voltage is a capital V, and the units for voltage are joules per coulomb or the volt. So a joule per coulomb is the same as a volt, which means that the units are actually the same as the symbol, which is kind of unique in all physics variables. This is something we haven't really seen before, but it makes our life really easy. The definition of voltage is the amount of energy each electron has. So as the electrons move through the circuit, they gain energy at the battery, and then they lose energy, or they use it up, they transform it into something else at the resistors. The amount of energy that each one is carrying around with it, or that each one uses, is going to be defined as the voltage. So a sample problem that you might see on your next math test is something like this. The battery gives off 60 joules of energy to 4 coulombs of electrons passing through. So we got these little electrons passing through the battery, and in a certain amount of time, 4 of them goes through, and the battery during that time loses 60 joules of energy. So the question is, how much energy did each one of those electrons get? And so on the variables quiz, I'd expect you to be able to say V equals 15 joules per coulomb, which is the same as saying V equals 15 volts. The second circuit variable is called current. The symbol that we use to represent it is a capital I, which is a little bit funny. It's not for any good reason, so that's one you'll just have to memorize. The units for this are coulomb per second, which is otherwise known as an ampere, and ampere can be abbreviated amp or just capital A. So current is similar to current with water, except it doesn't have to do with the speed of the electrons. It has to do with how many electrons are going past a spot in every second. So for example, if you might be looking at a light bulb somewhere and notice that in 120 seconds, 30 electrons pass through a resistor. And so you could use that information to determine the current. In this case, the current would be 0.25 coulombs every second, or 0.25 amps. So what that basically means is, if it takes 120 seconds for 30 of them to go through, that means that about a quarter of one is going through every second, or it would take 4 seconds per electron to get through that resistor. The third circuit variable is resistance. Resistance is represented by the symbol R, and the units for resistance, if you do the kind of algebra, you find this big ugly joule second per coulomb squared, but for our purposes you'll pretty much always see the ohm, and the symbol ohm is represented by the Greek letter omega, which looks like sort of an upside down horseshoe. You can see it there on the slide. Resistance is defined as how difficult it is for electrons to pass through any part of the circuit. Usually we're talking about the resistor here. So an example problem might say a 4 ohm toaster and a 1 ohm coffee maker are in the circuit. Which one has more resistance? Okay, and of course the answer is the toaster. It has 4 times as much resistance as the coffee maker, which means that it is 4 times harder for the electrons to push through that toaster than the coffee maker. The last circuit variable I would say is the most important one, which is power. This is the one that you'll see written on light bulbs and devices all the time because it tells how much energy is being transformed into something useful every second at that resistor. So power is represented by the symbol P. It's kind of a cursive uppercase P usually. And the units for power are the joule every second, which is otherwise known as the watt, or capital W. A sample problem you might get: in 30 seconds, a light transforms 90 joules of energy into light. And so that would mean that the power output would be 3 joules every second, otherwise written 3 watts. So that's it. Notice that, a lot of those variables kind of look similar because they have the same fundamental variables making them up. So you want to be really clear to yourself and do a lot of review about what the difference between those variables are and how do they describe and explain what's going to be happening inside your circuit. Thanks for watching.